Hello, Davidson Fellow Scholarship. My name is Emily Fan.
And my name is Ryan Dam, and we're excited to tell you about our project, Tech.
With that being said, our project Olfatech is a novel approach utilizing current diagnostic tools to create a better olfaction-based sensor for chronic disease detection. So our project is centered around VOCs, which are volatile organic compounds, and this can help with the detection of chronic diseases. How this works is that there's a change of VOCs depending on the body state. So when a person is normal and healthy, they will produce a natural amount of VOCs. However, if a person were to be diseased, such as having cancer, they will emit a large amount of VOCs corresponding to it. So with the right diagnostic tools, doctors will be able to detect and diagnose chronic diseases more efficiently. So current VOC diagnostic tools used to indicate chronic diseases have several problems. The most notable problem is their inability to detect a wide range of VOCs, and it makes it extremely difficult to narrow down on what diseases it could possibly be without doing multiple tests. Let's take into example Alstom Medical, which is the biggest VOC diagnostic tool of today, and they take breath samples from patients, and they can use their sensor to detect to see if the patient does or does not have lung cancer. And they do this by scanning and using up to only 16 VOCs, which is the max that their sensor can detect. And so even if they wanted to become more general and detect many diseases, unless they find a way to make their sensor be able to detect more than 16 VOCs, it would almost be impossible without having to run multiple tests, which is extremely time consuming, and it's very costly. And so this leads into the second problem, as Alstom Medical, alongside many other VOC diagnostic companies, are not in clinic. So they are their own company, and so patients have to seek out their own diagnostic. And this defeats the entire purpose of making a more effective diagnostic tool. We have the end goal of making Olfatech be part of clinic, which means that we want to make a handheld device, a very portable and small device that can be placed inside clinics and hospitals. So when patients come in to get their yearly annual checkup done, in addition to checking the blood work, checking weight, checking height, checking heart problems, they will also be checked for their VOC, their breath samples, and they will be told for early notification of if they might have a chronic disease. Compared to current models and methods, we've improved on this using a variety of different fields such as engineering, biochemistry, and physics to create a very unique system that can recognize multiple diseases and offers more accurate and efficient diagnosis. And so we do this by being able to detect more VOCs in our sensor, and we've created a very generalized sensor compared to the ones that are currently out on the market, which can only measure for one disease.
So to get into the development of our project, it was really a long journey to get to where our project is right now. And how it all started off was just wanting to do an idea that contributed to using VOCs for diagnostic purposes, that general field. And what got us interested in it, kind of interesting, is because apparently how researchers got interested in using those VOCs for diagnostics was because one of the things was there was a woman who apparently was able to smell Parkinson's, and now we know this is because of the VOCs, and we just found it interesting that that's what caused an interest in the field. So then we got interested, we started doing research, and then now we become passionate in using those VOCs for diagnosis purposes. And the idea that we decided to do in the field was, as Emily mentioned earlier, an idea that filled in the gap in using in diagnostics in terms of utilizing the VOCs, and that's in the initial detection, where you don't really have an idea of what disease is. You're not trying to specifically look for disease. You just have a wide range of diseases, nothing before, no prior testing. It's your initial, and you're just trying to look for a lot. And with current VOC detection methods, as Emily also mentioned, it's really hard because of how specific each test is to a specific set of diseases or VOC sensors, and you have to take multiple at a time, and that's really inefficient. So basically, we just wanted to make a general sensor that was able to detect a lot of VOCs, and we quickly found out why there's none right now, because current technologies can't really with the method of detecting molecules or chemicals, they can't really detect a wide range at a time efficiently. So then that led to us having to create a more novel approach to detecting chemicals. And with the help of input from UCI professors there and also physicians from Chalk, we were finally able to create the innovation that's Ovatech, our sensor, which utilizes a novel way of detecting chemicals. And that was really just looking at each chemical sensing method, current, seeing the problems, and then working with as the physicians and the professors to finally get to our idea. And that's really how it all went to now. And to wrap it up, me and Emily really believe that this project was able to further our passion for the field, because before we were interested, like I said earlier, but I was interested, but this project has really given us the opportunity to dive a little bit deeper, learn more about the biochemistry, the physics, basically the intricacies that goes into making such a biosensor, especially in the context of medical diagnostics. And it was a big project for us, working with other professors and physicians. So it taught us, or gave us that experience of being in a research group, working with others, basically in a research context and pivoting ideas. And we're really grateful for that experience and are thankful for the project.